Good morning, students. Hope all of you are doing fine. Today, we would discuss the exemplar problems from NCERT pertaining to the topic units and measurement. I hope all of you are having that particular textbook. In case you don't have, please check out the link, PDF link given in your school's website. From there, you download the questions. I will be selective in solving the numericals. So let's see the first one, that is 2.1. Here there is a number given 0.06900 and you have to identify the number of significant figures, and four options are given. Option A 5, option B 4, option C 2, and option D 3. Now we know, students, the zero conventionally put before the decimal is not significant in a numbers less than 0, less than 1. So this is not significant. This 0, which is after the decimal point and before a non-zero digit, is also not significant. 6 and 9 are significant because they are non-zero digits. This number is less than 1, so the trailing zeros in a number less than 1 are significant. So we have altogether 4 significant digits. So option number B is the correct answer. Second question, the sum of the numbers 2.2. Three numbers are given: 436.32, then we have 227.2, and we have 0.301. Question is the sum of these three numbers in appropriate significant figures. See, for summation, what's the rule? We have to add them. First, let me add them. So this is 2, this is 1, this is 3, 3, 6, 2, 8. We have 7, 6, 13, 6, 6. This is the answer. Now, in addition, the rule is that your answer you should restrict to as many decimal places, as many digits after decimal as are present in the number where we have least number of digits after decimal. After decimal, there are two digits, there is one digit, there are three digits. So where do we have least number of digits after decimal? In this number. How many digits are there after decimal? 1. So here also we should have only one digit after the decimal. So we should round it off to this digit. Now the next digit is 2, which is less than 5, so it remains like so. But in the question they have asked in appropriate significant figures. Now because they have given significant figures, see how many significant figures are there? 5. In this, 4. And in this 0 is not significant. This 0 is significant because it is between two non-zero digits. So 1, 2, 3. Which is least? 3. So you should express your answer in terms of least significant digit. So here we must have only 3 digits. So you will round it off and the answer should be 664. Why 4? Because this is greater than 5, so we will round it up. 2.3, using normal rules, you can do it yourself. 2.4 also you should do yourself. I will go over to 2.7. Measure of two quantities along with the precision of respective measuring instruments are given. There are two quantities A. A is given 2.5 meters per second plus minus 0.5 meters per second, and B is given 0.10 second plus minus 0.01 second. You have to find AB. AB is equal to question mark, and there are four options given. I'm not writing the options. Let us simply calculate it. First of all, see, students, A into B. These values, if you multiply 2.5 into 0.1, this will be 0.25. And what will be the unit? Second unit will cancel, it will be meter. So let the result be Z. So we have Z is equal to A into B. We have to find this. Now whether we should put 0 or not. First of all, see how many significant digits are there? 2. Here, this 1 is significant, this 0 is not significant, this 0 is significant. So there are 2 significant digits. Therefore, our answer should also have only 2 significant digits. So this 0 is not significant, 2 and 5 are significant. So this 0 you need not put. So the correct answer will be 0.25 meter. Now plus and minus delta z. This we have to calculate. We have z is equal to AB, so the absolute error delta z, we have to find that. So the relative error in z, delta z by z, you know, is equal to delta A by A, as per the rules for error arithmetics, delta B by B. Now what is delta A? For A, you see, this is the value of A, this is the value of delta A. So 0.5 by 2.5 plus delta B by B. So delta B is 0.01, this is 0.1. So this becomes 0.2, I think. This is 1 by 5, 0.2 plus. This is 0.1 again. Okay, 0.1 into 0.1 is 0.01. So this becomes how much? 0.3. Now this is delta Z by Z. So we need delta Z. So delta Z will be how much? Delta Z will be Z multiplied by 0.3. So 0.3 multiplied by Z. Z is 0.25. So this comes out to be how much? So 25 into 3 is 75. So we have this much, 0.075. After decimal, we should retain only 2 digits. And this is the error part. So there is no error. After decimal, there is no error. There is error over here. I have discussed earlier, the moment you have an error in some of the digit, there is no point in writing digits beyond that. So we will omit this 5, and as per rules of rounding off, this becomes 0.08. Therefore, our answer will be Z is equal to 0.25 meters plus and minus delta Z, that is 0.08 meters. Okay, so this is the answer. Yes. Then we have 2.8. Let's see the next question. 2.8. You measure two quantities as A is equal to, again it's given 1.0 meter plus minus 0.2 meter. And there is another quantity B, 2.0 meter plus and minus 0.2 meters. We should report correct value for root AB. We have to find root AB. 4 options are given. So I will take root AB as Z. So we have to calculate the value of Z. In principle, this method is similar to this one. But because there is root involved, I would like to do. So Z is root AB. Root AB can be written as AB to the power half. So A power half times B to the power half. So the error part should be calculated using this formula. Delta Z by Z is equal to half of delta A by A plus half of delta B by B. Now what is delta A by A? So half I am taking common. So delta A by A will be 0.2 by 1.0 and delta B by B will be 0.2 by 2.0. So this becomes half, this becomes 0.2 plus This becomes 0.1. So this sum is 0.3. 0.3 by 2, 0.15. This is delta z by z. Now when you calculate root AB, now what is the value of root AB? The true value will be root under A into B. A into B is 2 into 1, that is 2. Root 2, you know, it's 1.414. Correct to 3 places of decimal. Now how many significant digits are there? 2. Here 2. So in your result also you should have only 2 significant digits. So we will omit this 1 and this 4. So this will approximate to 1.4. So together with error, I think now you can do it yourself. We have got delta z by z. So delta z upon z is how much? 0.15. From this equation we calculate delta z. So delta z will be 0.15 multiplied by z. Now z is how much? 1.4. So z is 1.4. So your answer will be, a z value will be 1.4 meters plus minus delta z. Delta z you will get from here, and you will use the same concept which I have discussed over here. Wherever you get the error, the digit next to the error part, you have to drop it. I think this much you can do, so I am leaving this part for you. You should get the answer as 1 point. This you should round it up to 0.2 meters. Okay. So your answer will be 1.4 meter plus minus 0.2 meters. Next. .12. It's given if momentum they have taken as P, area capital A, and time capital T are taken to be fundamental quantities. Instead of mass, length, and time, P, A, and time they have taken as fundamental quantity. Then you have to find the dimensional formula for energy. See, the correct method will be, let us take energy to be proportional to P to the power something, area to the power something, T to the power something. This is the actual method as far as dimensional analysis is concerned. Then write the dimensions of E, P, A, T and then equate. For energy, the dimensional formula is M L square T to the power minus 2. Same as that of work. Then is equal to some constant, you can write dimensionless constant K, but that does not have any dimension. So for P that is momentum we have M L T to the power minus 1 to the power A. Area we have L square, so to the power B, time T to the power C. So collect M L T's. So this become M to the power A. There is no M anywhere else. L to the power A here, 2B, and then we have T to the power minus 1 into A, that is minus A, and here we have C plus C, and here we have ml square T to the power minus 2. So if you equate the coefficients for mass, we'll get A is equal to 1. For length, A plus 2B is equal to 2, and for time, minus A plus C equals to minus 2. Now if you put value of A as 1, so 2B will be 2 minus 1, that is 1, so B will be half. And from here we'll get C is equal to A minus 2. A minus 2 is 1 minus 2, that is minus 1. So with these values, our energy, which we have written as this, will have same dimensions as P to the power A. Now A is 1, so P to the power 1. A to the power B. Now B we have got half. and t to the power c. C is -1. So this will be the answer. P to the power 1, e to the power half, t to the power -1. But you could have done straight away. This is the actual method. In the beginning, actually, I would recommend to do it like this. But because these are very common quantities, it can be done directly using some logic. For example, you see energy. Energy is nothing but work. It should have same dimension as that of work. Work is force times displacement. Force is rate of change of momentum. So momentum by time. So for momentum, what dimension we have to use? P. So we write P for momentum. Change in momentum also has same dimension. For time, what you have to write? T. And this is distance. And we want to use area. Area has dimension of distance square, length square. So distance will have dimension of root area. So this would be the answer. So using logic, you can write the answer directly. So P to the power 1, A to the power half, and T to the power -1. But it will not be always so easy as in this particular case. So it's better to do it as per the traditional method. So let's quickly switch over to some more problems. Some of the questions I had already discussed, so I'm leaving them also. Next, some very short answer questions are there. Here, this is a good question. Is the 2.23? There is a function f theta, function of variable theta, and it is defined as 1 minus theta plus theta square by factorial 2. I don't know whether you understand this factorial 2 or not. Factorial 2 means 2 into 1. Factorial 3 means 3 into 2 into 1. Starting from that number, you go on multiplying the preceding digits till you reach 1. Factorial 10 will be 10 times, 9 times, 8 times, 7 times, 6, 5, 4, 3, 2 up till 1. So anyway, this is a number. Since it is a number, it does not have any dimensions. Okay. So we call it as factorial. So minus theta cube by factorial 3 plus theta power 4 by factorial 4 minus dash the dash. It is an infinite series. Okay. Question that they are asking in this is this: why is it necessary for q to be a dimension for uh, theta? It should be for theta to be a dimensionless quantity. Question they're asking: why should theta be dimensionless? So based on principle of a homogeneity of dimensions, we can answer this question. See, here we have minus plus and so on. See the first digit, it is 1. It is clearly a dimensionless number. Now we know that we can add or subtract only such quantities which have similar dimensions. Since theta has been subtracted from 1 is dimensionless, that's why theta should also be dimensionless. That is the reason to this particular question. Okay. Next, I will discuss 2.29. Let me read the question for you first. During a total solar eclipse, the moon almost entirely covers the sphere of the sun. Write the relation between the distances and sizes of the sun and the moon. So just you have to write the relation. It's which eclipse? It is solar eclipse. So suppose this is the sun. This is a point on the earth. So complete solar eclipse means the view of the sun from earth, this is earth, gets obstructed because of moon. So the moon is supposed somewhere here. So this is moon, this is sun, this is earth. Question they have asked, write the relation between distances and sizes of the sun and moon. Size means radius. So suppose radius of sun is Rs, radius of moon be Rm, distance of sun from the earth, this distance we write as suppose you choose as per your wish, distance of sun from earth, and this is distance of moon from earth. So between these four quantities we have to find the relation. Now see students, this sun has got completely blocked by the moon. Now this line of sight and this line of sight, they touch at the endpoints of the diameter of the moon and the sun, like so. So this we call as angular diameter, this angle that we call as angular diameter, let me write it as alpha. So alpha for moon, alpha will be this diameter. So this diameter will be how much? This will be twice the size of radius. So 2 rm by the distance. What is the distance? Distance of moon from earth. But if you consider sun, then in this alpha will be written as this size. This size will be twice the radius of sun by its distance from earth. So 2 will cancel. This is the relation. Rm by Rme is equal to Rs by Rse, where the symbols have the meaning which I have discussed. Next, I will discuss 2.30. If the unit of a force is 100 Newton, for force the unit is taken to be 100 Newtons. If for length the unit is taken to be 10 meters, and for time the unit is taken to be 100 seconds, then what is the unit of mass in this system of units? For mass, what should be the unit? One unit of mass is question mark. So this is a question, students. So generally we have prescribed set of units, but if we assume these to be the units, one unit of force is 100 Newton, one unit of length is 10 meters, one unit of time is 100 seconds, then what should be the one unit of mass? To do this question, we must have a relation between these four quantities. So what we have, force is equal to mass into acceleration. Acceleration is length by time square. Force is mass into acceleration. Acceleration is meter per second square. So this much. So the mass dimension is same as dimension of force into square of dimension of T by dimension of L. Therefore, one unit of mass, looking at this dimensional formula, you can write the unit of mass. It should be 1 unit of force into square of 1 unit of time. So I can write this square like so, divided by 1 unit for length. So let's write the values. For force, 1 unit will be 100 Newton into, for time it is 100 seconds. We have to square it, divided by, for length it is 10 meters. Length power is 1, so it remains 1. So this will become 100 into, this is 10 square, this is 10 to the power 4. So together they become 10 to the power 6 by 10. So it is 10 to the power 5. Okay. So this is the answer. Instead of kg, you can write in terms of this Newton second square per meter. Okay. Then I would like to do 2.34. So let's see 2.34. An equation is given over here. Y equals to a sine omega t minus kx, where x is distance, t is time. Now the question, the displacement of a progressive wave is represented by this equation y is equal to a sine omega t minus kx, where x is distance and t is time. Write the dimensional formula for omega and k. So we have to find this, we have to find this. First of all, you see that this quantity inside the bracket, which is the argument of sine, it must be dimensionless. So we know argument of trigonometric functions, they are dimensionless. That means they do not have any dimension. Therefore, omega t minus kx should not have any dimension. It is dimensionless. Okay, so that was the hint to this particular question. If this quantity is dimensionless, now see, this is negative, this is minus. Two quantities whose subtraction or addition, if it is dimensionless, it means the individual quantities must also be dimensionless. So omega t should be dimensionless and kx should also be dimensionless. Now easily you'll get the answer. If omega t is dimensionless, that means omega dimension must be the inverse of dimension of time. Then only this product will have zero dimensions. What is dimension of time? T. So reciprocal t to the power minus 1. What I mean, if omega will be t to the power minus 1, as we have explained there, time is how much? T. Then only they will cancel. Plus 1 and minus 1, it becomes 0 and the quantity becomes dimensionless. Likewise, k should have dimensions which should be reciprocal for the dimensions for x. So dimension of k should be reciprocal for dimension of x. X is distance, that is length. So here we will have length inverse. I hope these solutions are clear to you. Next, some more questions we will discuss. 2.36. Let me read the question for you. A new system of units is proposed in which unit of mass is alpha kg. So mass, its one unit is alpha kg. So this is unit. Unit for mass is alpha kg. For length, the unit is beta meters. And for time, the unit is gamma seconds. How much will 5 joule measure in this new system? 5 joule will be how much in this system? Now joule. Which physical quantity has the unit joule? We know it's energy. So let us first write the dimensional formula for energy in terms of these quantities. So energy we know students, that is same as work. Work is force times displacement. Force is ml t to the power minus 2 times displacement, so it becomes this much. So it is similar to one of the questions which we did earlier. The first step is to write the dimensional formula of the quantity which is being asked. What's the unit of energy? Joule. 5 joules. So 1 joule is the 1 unit. So 1 joule should be in this new system. For mass, we'll write what is the unit? Alpha kg. Power of mass 1, so power is 1. For length, what is the unit? Beta meter. Power of length is square. So you go on writing the units for mass, length and time and fit them in this particular formula. ml square t to the power minus 2. For t, we have gamma second. Power is minus 2. That's it. So 1 unit of energy becomes alpha beta square gamma to the power minus 2 and then write the units kg meter square second to the power minus 2. This is 1 unit of energy, that is 1 joule. In question, they have asked about 5 joules. So, therefore, 5 joules of energy will be 5 times alpha beta square gamma to the power minus 2, and the unit remains so. Next, we'll discuss 2.38. So, this question is basically based on calculation of percentage error. Here, a quantity x is given in terms of a, b, c, and d as x is equal to a square, b to the power 3, c to the power 5 by 2, d to the power minus 2. And it is given that the percentage errors are 1%, 2%, 3%, and 4% respectively in a, b, c, and d. First part is to calculate percentage error in x. So that is simple, students. You know the percentage error in x as per the rules for arithmetic for errors. It will be 2 times the percentage error in A plus 3 times the percentage error in B plus 5 by 2 times the percentage error in C and plus 2 times the percentage error in D. We should not write minus. D to the power minus 2 simply means 1 by D square. So whether it is multiplication or division, always we should write plus. That's it. Just you have to calculate. So 2 times percentage error in A is 1%. So 3 into 2%, 5 by 2 into 3%, and 2 into 4%. So this much percent is the answer. Now if you calculate this, so this becomes 2 plus 6, 8, plus 4 into 2 is also 8, and this is 15 by 2, that is 7.5%. So 8 and 8 becomes 16, 16 plus this 23.5%. So that is the answer to the first part of the question, that percentage error in X is 23.5%. Now part B is important. If X is calculated to be this much, then to what value you should round it off? For that, first we need to calculate the absolute error in X. See, this is percentage error. How do we calculate percentage error? Absolute error by actual value into 100. This is 23.5. This gives us the value of delta x as 23.5 into x. What is x? 2.763 divided by 100. So our delta x becomes 0.235 into 2.763. Now don't bother about this calculation because they have not asked us to find delta x. Our main purpose is to find the number of digits to which you should round it off. For that you have to see that where does the error for the first time creep in. So you need not calculate this exactly. If you wish, you can calculate it. You will get 0. Then 2, 3, 4, something like that you will get. But the moment you get some error in a particular place, there is no point in writing more number of digits after that particular location. Just you see, this is, I don't wish to calculate this. Suppose this is 2.8 and this you can take as 0.2. 0.28 into 2, that is 0.56. So it is nearly 0.56. Please calculate it yourself what actual value. So whatever you do, you will get some digits, some more number of digits here. It may be 5, then something like that you will get. The point is there is no error before decimal. And just after the decimal, at the first digit only there is some error. Since there is some error in the first digit after decimal, there is no point in writing these digits. They will not make the calculation more precise. So we should write the answer, we should round it off to only one place after the decimal, because the error enters for the first time at this location. After decimal, this is 7. Up till here we have to write. But The next digit is 6, which is greater than 5. Therefore, 2.763 correct to one place of decimal after one digit after decimal, it should be rounded to get 2.8 as the answer. Next, we will discuss 2.41 uh, before ending today's discussion. This is the last question that I would like to discuss. So 2.41. Let me read the question for you. An artificial satellite is revolving around a planet of mass m and radius r. So there is a planet of mass m, radius r, and a satellite which is artificial is revolving around that planet in circular orbit of radius r. Suppose this is the planet. This planet has mass m and radius r. This capital R is the radius of this planet. Okay. And there is a satellite which is revolving around this planet in a circular orbit. So I have done an ellipse. So you should take it as a circle. And this radius is given as small r. So capital R is the radius of the planet, and small r is the radius of the orbit of the satellite. Satellite is revolving around the planet. From Kepler's third law, this statement is given. Square of period of revolution, time period of revolution, its square is proportional to the cube of radius of the orbit. So this is given in the question. It is known that t square is directly proportional to r cube. You have to show using dimensional analysis that t is equal to some dimensionless constant k divided by r into root under r cube by g, where k is a dimensionless constant and g is acceleration due to gravity. So okay. So we have to obtain expression for t. From this t square proportional to r cube, first of all we can see that t will be proportional to its square root, that is r to the power 3 by 2. That is known to us. Apart from r, we need capital R and we need small g. According to question, t is also proportional to capital R and g, but to what powers we don't know. So let the powers be a and b. So t is equal to, if we combine them, we write t is equal to some dimensionless constant k into r to the power 3 by 2, that is known to us, into capital R to the power a, g to the power b. Let's write their dimensions. T is m to the power 0, l to the power 0, t. No dimensions because it is dimensionless. R is l to the power 3 by 2. This is also l to the power a, and this is g. G is acceleration due to gravity. So acceleration is lt to the power minus 2, and to the power how much? b. So this, if we equate, there is no m, so m to the power 0, l to the power a plus 3 by 2. Oh, wait. There is 3 by 2, there is a, there is one more 1, so plus 1. And then we have, so this 1 to the power b, sorry. Let me rectify myself. There is 3 by 2, there is a, and this is 1 to the power b, that is b. And then we have t to the power minus 2 to the power b, that is minus 2b. So let's combine them. So we get l to the power a plus b plus 3 by 2 t to the power minus 2b. And here we have m0, l0, t to the power 1. Let us now equate the coefficients, equate the dimensions or the powers for mass, length and time. For mass, 0 is equal to 0, so no need to write that. For length, 0, here a plus b plus 3 by 2. And for time, 1, that 1 will be minus 2b. So this gives us the value for b. B will be minus half. And here If you put the value of b in this equation, we'll get a. A will be how much? Minus b minus 3 by 2 is equal to minus of b will be plus half minus 3 by 2. This implies a will be half minus 3 by 2 will be minus 1. Therefore, our answer will be T. This one you see. This one. So T is equal to some dimensionless constant K. This was known to us R to the power 3 by 2. Capital R to the power A. A is minus 1. And G to the power B. B is minus half. Now you can compare over here. So this we can write as T is equal to K. R to the power 3 by 2 I can write as root under R cube. G to the power minus half, it will go down and will become G to the power half, that is root G, and R to the power minus 1 will go down and will become R. So this becomes T is equal to K under root R cube by G, and this R we can put here. Now this is the relation which was asked in this particular question. So we did a number of questions from NCERT Exemplar of Unit 2. I hope this will help you. I have not done all the questions because others, based on these particular ideas, I think you will be able to do them yourself. See you in the next class. Even then, if you have some doubts in some of the questions, you can put them in the query link. I'll be happy to resolve those issues. So see you students in the next class. Till then, thank you. Take care.